We wait a while more for the rest. Anyway, if later the Zoom meeting end, right, you'll just join back. Because just now it ended on its own. I also don't know why. Don't know will happen again or not. Okay. So FYI. Wait a while more. We wait another maybe 2-3 minutes. You all can take out the last week worksheet first. Because I will go through the part that I haven't went through yet. Then yeah, then we will do the worksheet for today. Okay. So weird. Why the rest haven't joined? Okay, never mind. Show you a video. Okay, so today, right, last week we talked about the, what is it called? Last week we talked about the speed, the exothermic, endothermic, right? Okay, wait, I show you all the worksheet first. Okay, so last week we talked about the endothermic, exothermic, okay? Then we also talk about the speed of reaction, like what is the 4 factors that will affect the speed of reaction. So the 4 factors is concentration, pressure for gas, particle size for solid, and also the temperature, the last one. Okay, so today, right, we need to talk about something called the redox reaction. Okay, so, okay, before I go through the notes, right, I show your video lah, okay? So see the rest will join or not. Okay, we watch a video first. I won't show the whole thing lah. Like maybe until halfway I will stop already. Okay, so should be can see, right? Okay, should be no problem lah. Last time I show video, no problem. So should be no problem also.
We're going to take a look at redox reactions, which are reactions in which... In today's video, we're going to take a look at redox reactions, which are reactions in which oxidation and reduction both take place at the same time. And to do this, we'll cover displacement reactions, ionic equations, and half equations. We saw in a previous video that one meaning of oxidation is the gaining of oxygen, and that reduction is the loss of oxygen. For example, if aluminium reacts with oxygen to form aluminium oxide, we can say it's been oxidized. Whereas if we take away that oxygen, then it's been reduced. The terms oxidation and reduction can also refer to the loss and gain of electrons though. And instead of just remembering which is which, most people use the mnemonic oil rig, which stands for oxidation is loss, reduction is gain, and this refers to electrons. So if we had a magnesium atom and it loses 2 electrons to become a 2+ ion, then it's been oxidized. And if it gained those 2 electrons back, then it would have been reduced. Most of the time though, these oxidation and reduction reactions don't happen by themselves. Instead, they both take place at the same time. Because if one substance loses electrons, then another substance has to gain them. And because both happen together, we call them redox reactions, which just means reduction-oxidation reactions. For example, if we react some magnesium with a dilute acid, which we can represent as H+, because that's the important part of an acid, then the magnesium atoms will lose 2 electrons and be oxidized, forming magnesium 2+ ions. Meanwhile, the hydrogen ions will gain those electrons and so be reduced to neutral hydrogen atoms in the form of hydrogen gas. Another place we see redox reactions is in displacement reactions, which involve a more reactive metal displacing a less reactive one. For example, if we look at our reactivity series, we can see that calcium is more reactive than iron. So if we added some...
Yeah, actually the main thing is just to give you an introduction. So not much things. Okay, wait. Okay, the rest never join. Correct, right? You all got join means this is the correct room, right? Let me check meeting info. Yep, correct. Never mind. Okay, so okay, just now redox, right? Okay, basically for redox, right? Redox means, okay, if we split the word, right? Okay, let me highlight lah. RED and OX. Wait, let me rewrite. Okay, RED. Okay, then you got your, okay, green color, you got OX. Okay, so redox, right? Okay, RED stands for reduction. Okay, so this one is reduction. Okay, then OX, right, stands for oxidation. So for redox, right, it basically means that these two reactions, right, occurs at the same time. Okay, so just now if you got listen to the video, right, or you got take note, right, they got mentioned, okay, reduction and oxidation, right, they don't occur, how to say, they don't occur separately, they always occur together. So that means if something is being reduced, another thing is being oxidized. That means they will take place at the same time. Okay, but we need to know like which one get reduced, which one get oxidized. So that's why we need to learn this. Okay, so for oxidation, right, just now they got say, okay, so here there's a bit more. Okay, so for oxidation, it means that it is the gain of oxygen, okay, loss of hydrogen, loss of electron. This one they got mentioned just now. Then increase in oxidation state. Okay, this one later I will explain what it means. Okay, so this one must remember. Oxidation is gain oxygen, lose hydrogen, lose electron, increase oxidation state. Okay, oxidation state later I will explain what it is. Okay, so just take it as it is first. Then for reduction will be the opposite, exact opposite. So it will be the loss of oxygen, gain hydrogen, gain electron, then decrease in oxidation state. Okay, so this one you must memorize, or like oxidation is what? Is gain oxygen, blah 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 blah. That kind. Need to roughly know lah. Okay. So okay, then for oxidation state, right? Okay, this is the guideline. Okay, this one very important. Okay. Okay. Because right, okay, why how to say, okay, why we need to know the oxidation state, right, is because usually oxidation state, right, is the so-called the more universal way, okay, the more universal way of determining is it oxidation or reduction. So for oxidation is the increase in oxidation state, right? And then for reduction is decrease. So okay, we go through some guidelines first, then later I show you like how do you know is it increase or decrease. Okay, so for elements, right, okay, as long as it is element on its own, like sodium, hydrogen, H2, O2, Cl2, as long as it is on its own, it's an element, the oxidation state for these, right, is it will be 0, okay? So this one must remember. Then for example, for group 1, right, it will basically be the charge. That means it will be +1, okay, for group 1 metals. That means like, for example, sodium in here, the oxidation state is +1, potassium also +1, lithium also +1. Not talking about the whole thing, it's just the ion itself. Then from group 2, right, this one also +2, calcium also +2. Aluminium is group 3, so it's +3, okay, so on and so forth. Then group 7, same thing, it will be -1. So it's about the same as your ionic compound, okay. So group 1 is +1, group 2 is +2, then group 7 is -1, group 6 is -2. Okay, then for hydrogen, right, hydrogen usually is +1. Then for oxygen is usually -2. Okay, but later we will see that. Okay, so just take note of this. Later I will show you how to determine. Okay. Okay, like so for example, right, okay, so maybe I rewrite the example. Okay, so for example, they say SO2, right? Okay, so oxygen, just now from the table, we already know the guideline is each oxygen, right? The oxidation state is -2, correct? Okay, each oxygen, okay? But since right here you got 2 oxygen, so total here will be -4. Okay, so in order for a compound, right, the oxidation state must be balanced. So if the oxygen part is -4, that means my sulfur will be +4, so that they cancel out each other. So that's why the oxidation state of S is +4. Can you see the sentence here? So the oxidation state of S is +4. Okay, because this one is a compound, it's a balanced compound, so the overall oxidation state should be 0. So whenever we talk about oxidation state, right, we are talking about the element itself. That means like specific element. So the oxidation state of sulfur in sulfur dioxide. Okay. Okay, then I give you, then we do the guided example one together. Okay, we do the guided example one together. Okay, this one right, a bit similar, but okay. So let's write down this first. Okay, so key thing is, okay, so same thing, each oxygen, right? Okay, the oxidation state is -2, correct? This one is universal, okay? So if I got 4 oxygen, right? So 4 oxygen, the total oxidation state will be, okay, I put OS. OS means oxidation state. For oxygen, the oxidation state is -8, correct? Because you times 4. Okay, OS means oxidation state. Okay. The oxidation state is -8. But okay, but okay, but this one, right, the charge is 2 minus. That means this one is not a compound, this one is an ion, okay? So overall, there is a charge. So the overall charge, right, is -2. So in order for it to be -2, right, okay, so okay, I let the oxidation state of sulfur be X lah. Okay, for example, this one is X. So that means X plus -8, right? I will get -2 because the overall charge is -2. Okay, so that's why here there is this -2. Then you find what is your X. Okay, so it's like solving algebra that you bring over. Okay, so you will get -2 plus 8. So you will get +6. Okay, so that means the oxidation state, okay, oxidation state of S in SO42 minus is +6. Can? Okay. So it's like that. So you see, right, if here this one is +6, okay, the sulfur is +6, then the whole oxygen here, right, is -8. So +6 -8, just nice, you get -2. Okay, so that's how it works for ions lah. But usually compound is the whole thing must balance out, so you should get 0. Okay, like the one that I go through just now. But because this one is an ion, so the oxidation state must be the charge itself. Can? Okay, so okay, later we'll do more on oxidation state. So now you still a bit don't get it, it's fine. We will do it more later. Okay, so remember, right? Okay, I go back to the table. Okay, so for oxidation, right, it means loss of electron. Okay, just now they got say the what, the oil rig, the oil rig. I don't know if you all got listen. Oxidation is loss. Okay, reduction is gain. Okay, but this one is they talking about the electron and hydrogen. Okay, so oxidation is loss of electron, reduction is gain of electron, oil rig. So right, when we say that something donates electron, right, donates means you lose, okay, donates, so it means that it is oxidized. Then if it receive, right, means gain, it is reduced. Okay, so this is what they're trying to say. Okay, this one very important. If you have, you can help me highlight. Okay, oxidizing agent, right? Okay, this one a bit okay. Oxidizing agent, right, is something that causes other substance to oxidize while it is self-reduced. That means oxidizing agent, right, it is reduced on its own, but it causes other thing to oxidize. Get it? Okay, never mind. Just highlight first, okay? Causes other things to reduce while it is self-oxidized. Okay, so that means, right, okay, if the substance undergoes oxidation, it will be a reducing agent. Okay, so counterintuitive lah. If the substance undergoes reduction, it will be an oxidizing agent because it oxidizes others but self-reduce. Okay, so these two must memorize. Okay, later I will go through again, so just take note. Okay. Y'all give me a while. Thanks. So oxidizing agent means it is self-reduced. For reducing agent means it is self-oxidized. Okay, so just take note of the difference. Just remember lah, okay. Oxidizing agent means itself is being reduced. Then reducing agent means itself is oxidized. Okay. So okay, the last part for redox, right? That's all. The last thing is this one already. Okay. For this one, you don't. Let me think. Oh, okay. Okay, so this one is, okay, so this is the common oxidizing agent. Okay, this one must memorize, okay, no choice. Okay, you just need to remember the name. The chemical formula don't need to know. Okay, these two don't need to know. You just need to remember the name. Okay, then the color change. Okay. Okay, so this one is the oxidizing agent, then this one is the what am I talking about? This one is the name, okay, then the observation. Then for reducing agent, right? This one is the name, this one is the observation. This one don't need to know, the second one. You just need to know this. Actually, I remember got one of it you don't need to know, so but I can't remember is which one. I think is it dichromate? Because I remember is for pure chem only. Combined chem, I think don't need. Okay, y'all give me a while. I check very fast one. Combined chemistry syllabus. Yeah, okay. So you all take combine, right? Combine, you don't need to know the first one also. Okay, you don't need to know this one. You just need to know these two. Okay. So easier for you all, right? So just remember, okay, I highlight the key thing. So common oxidizing agent, okay. Okay, memorize this one. Acidified potassium manganate 7. Okay. The observation, right, if a reducing agent is present, is it will change from purple to colorless. Okay. Then another thing you need to memorize is common reducing agent is aqueous potassium iodide. I cannot highlight. Okay. Then it will change the color. The color will change from colorless to brown. Okay, colorless to brown. Okay, yeah, so that's all for the redox. Okay.